and top of the morning to ya. How are you all doing? I hope you're having a great Sunday so far. It is cold and fine here in Melbourne. Cold and fine. And, okay, getting right into it. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Cool. Okay, I need to. Here we go. I'm going to make myself a little list. PNP machines. What else? What else was there going to be? Register, or ERP, as Princess Fiona and I refer to it, and BeetleBot and RRM. So I just had Vic on chat a few minutes ago. But first, good morning to Crispian, Michael Wires, myself, Tinker, Gavin Jackson, Tabraze. Hello, Tabraze. Yes, as you said, I haven't seen you for a little while. Stephen George, Sharky, Imogen Ann. Welcome, everybody. Welcome. Let's see what's going on in the chat. And where are we? Scrolling back. Gavin said, morning, cold people. Brisk and invigorating, says Michael. Yeah, but the sky is blue. The sun is coming out. I like mornings like this. I like it when it's brisk, but there is blue sky. And you know that the day is going to turn out nicer. Well, I hope it is. What is the day going to be like today? I haven't looked at the weather report, but it seems fine. Michael says, stream starts upside down, on mute and with Ukrainian subtitles. We can only hope. Okay, where are we? Yeah, wakey Crispian. AI generated button push. Crispian says we froze overnight again, so it would have been below zero in the Ballaratish area. Yeah. Oh no. Gavin said it sounds like a plan. We don't do plans here. No, I have plans. I just then throw them over my shoulder and act like they don't exist. Seems to have settled the smoke out of the air for the moment, says Tinker. Yeah. Okay. Where are we? Yes, and good morning to John Whips and Grant Maisels. Speaking of Grant, so last week, I'm going to jump into this for a moment, before I forget it, and then I'm going to switch to a couple of other topics briefly. I'm going to branch off main, and then we're going to merge, or maybe we'll just leave those branches dangling. Yeah, we'll leave them dangling because we're going to come back to them anyway. So last week, I spent the whole stream basically in a bad mood, annoyed at Autodesk for things they've done to Fusion, or things they haven't fixed in Fusion. Anyway, I'm not going to have all that bad mojo again this week. So I ended up spending a lot of the stream just talking about power switches. We didn't actually even do anything useful on BeetleBot last week. I intend to rectify that today. I want to restore balance to the force and have a nice productive stream. Get through a bunch of design stuff, make progress on it. And Simon suggested a side mount slide switch right near the end of the stream, I think it was. Sent through details of a part which looked kind of similar to this, but it was 1 amp rated. And Grant sent me this one, which is similar to Simon's suggestion, which was on the right track, but it wasn't quite there. And this one is 3 amp rated, which puts it, right in the sweet spot. It's enough. We've got all the mechanicals here, and they're not expensive. It's just a basic general purpose side mount slide switch with mechanical mounting. You can see it's got the stakes. A lot of them, if I click on this, bring it up bigger, a lot of these sorts of switches have the pins that go into the board, and they rely entirely on the pins for their mechanical mounting. But because this is side mount, the force is some distance away. It's off the axis of the pins, which means that the whole body of slide switches is prone to twisting. And this one gets around it by having these tabs sticking down. So these go through holes in the PCB, solder them in place, and it makes it really strong. So I think this is a pretty good candidate for a power switch for a BeetleBot. And yeah, did I add any to my cart? What have I got in my shopping cart right now? There are 4 things there. Why do I have 4 things? Oh, I see. So I had, was this the one from last week? I think this might be the one that Simon was suggesting. Oh no, this is a 2 amp. So this one, I'll take this out of my cart. This is a slide switch exactly like I was describing. It relies on the stakes for its mounting. It doesn't have those 2 mounting, it relies on the pins for mounting. It doesn't have mounting stakes. And you can see that it's rated at 2 amp. So let's trash that one from my cart. And this was another candidate that I was looking at, which was more of a flip-flop toggle sort of switch. These are quite nice as well. And they do have a really positive snap action, which is nice. So I'm kind of undecided about which one I want. I think I'm going to order both. So this one has the mounting stakes, but it is physically a lot deeper than the slide switch. That may end up being the limiting factor. What's this one? Oh, that's right. This is the diodes we were talking about last week. I'm going to get myself a reel of SS56s in the flat. So SMA footprint, but the really thin one. Yeah, probably just switch to those as my go-to little rectifier type diodes. 60 volt, 5 amp rated. They're not super small, but they're okay. And it seems that the forward voltage drop on these is actually more respectable than I remembered. I thought that the SS56 series was so dated now that they were totally eclipsed by more modern diodes, different chemistries or different physics. But yeah, they seem okay. The forward voltage drop on them is quite small. So yeah, they're good. And it means I can keep the same footprint that I use on existing designs. So if I'm building more boards in future that I've already designed, typically with an SS56, it just fits on the same footprint, on their SMA footprint. It's just a different height setting in the pick and place machine. Ooh, that's another subject. It's a different height setting in the pick and place machine because when the machine puts the part on the board, it has to know how thick the part is to stop the nozzle that distance above the surface of the PCB. Yeah, so minor tweak on the pick and place setup, but that's fine. And this is the one that I've just added to my cart, which is the one suggested by Grant. Now, I am going to get into, yeah, I'm going to get into some BeetleBot stuff. Oh, Crispian says, what about a push-on, push-off switch? That's an option, yes. I don't... oh, good morning to the Helper 4566 and to David Crisp. So that is an option. All right, I'm going to get back to switches and BeetleBots and all of that sort of thing in a moment. But first, let's see, camera uploads. I've got to have a look. I just took some photos right before the stream of, let's see. So, for those of you who came to the barbecue last week, yeah, you would have seen new machines. This is not the big fancy new machine. This is a little baby new machine, but still very, very nice. Point being, which one is it? That one. Yeah. Point being, I am now in the fairly clear on my plan in terms of what I want to do with all the pick and place machines. So, right now I have, if you count Mickle Make It, and I do, because Mickle Make It has history and I love it, and I don't think I ever want to part with it. I can see it from here. It's such a cool pick and place machine, and I spend so much time designing and building that machine and then iterating on it to make it work. And it built a bunch of boards for me, including a whole bunch of open hardware mini-conf boards and other things. So, end result is, right now I have 6 pick and place machines, which is too many. So, my plan is, ideally, I want to sell 3 of them and keep 3. So the 3 that I want to keep, 1 is Mickle Make It, because it's just my personal baby. It's the DIY thing that if somebody else wanted it, it would be so much messing around to learn all of the quirks of it that I don't think it's really worthwhile. And also, it's my creation. It's bordering on artwork. Like it has personal value to me or meaning to me. So I'm going to keep Mickle Make It. I'm also obviously going to keep the big new KO S600, which is the fancy new machine that is currently sitting in my loading dock, and many of you would have seen last weekend at the barbecue. So that's the 6 nozzle machine with 9 cameras and big slab of granite in the middle so that it can work at ridiculous speeds. And that's going to become my new primary machine. That's going to be swapped into the cleanish room. Then I'm going to keep, ideally, I want to keep KO number 1, which is the one that right now we are using as our primary machine. And I want to probably wrap it in plastic, roll it off to the side, and keep it there as a cold spare, ready to pull into action again at short notice. Because I'm in a situation now where I'm so dependent on putting boards together, and my clients are so dependent on business continuity based on my ability to put boards together, that if I have some kind of a fault, I have some big situation where my primary pick and place machine has a problem, I need a secondary that I can run boards through. It may be slower, it may take a fair bit of setup if it's not ready to go. Obviously transferring a bunch of feeders, it can't hold as many feeders, so jobs might have to be done less efficiently. They definitely have to be done less efficiently, but I can at least get stuff done. So I want to have the S600 as my primary machine and one of the KO A4s as my secondary machine. And that means what I need to sell is this machine, which is the TVM 920, TYM, this one, which is a little bit like the KO A4, but it's a bit smaller and it doesn't have the conveyor belt through it. So to put boards in, you sit boards on little mounting stakes or holders. So you adjust these little things to put the holders in the correct place, and you sit the board on it, and then the thing does its job, and then you manually take the board back out and put the next board back in. So it's a 4 nozzle machine, and as a desktop class machine, this is really nice. It just doesn't have the conveyor through it. So this one I want to sell. This one I want to sell. This is my 3rd KO. So this is the KO A4 number 3, and this one is unmodified. It's still factory original, all the original camera array in it, that sort of thing. And I also want to sell this one, which is KO2. So this is the 2nd KO machine. I should probably crop that picture in. Let's do that. I'm going to go to there. Yeah, that'll do. Tools, croppity. Yeah, so this is my second KO. You can see the first KO is just to the left of it there on the edge of the photo. The one on the left is the one I want to keep. The one on the right has been converted to run OpenPNP. So the camera array has been replaced with a single higher resolution bottom camera, and yeah, it's got the OpenKO interface on it and all of that sort of thing. So this one is running OpenPNP right now. And so I want to sell that one as well. So what I want to sell is this one, OpenPNP converted KO-A4, this one, factory original KO-A4, and this one, which is the TVM 962, I think it's TVM or TYM, I'm not that familiar with the model. TVM 920, Jihei TVM 920, which is a nice machine. It is surprisingly nice. Yeah, anyway, that is what I want to do. And I need to do that, firstly, to get back some to get back some money to help pay for the S600, and secondly, to make space, because I am so jammed up now with these physically very large machines sitting around the place. So Mickle Make It doesn't really count because it's fairly small, it sits off to the side, but I now have 5 full-size, like big pick and place machines, and it just takes up so much space. I need to sell off some of them to make room to be able to move the jigsaw puzzle pieces back in around. Stephen says, so it's like John, surprisingly nice. Is it surprising that I'm nice, or am I nice? I don't know. What is that? Oh, David said, do you have photos of the new ones for those who couldn't come to the barbecue? Ah, good question. Let's see what I do have. Camera. I'm not even sure. Oh, I do have some photos. I've already posted some photos in Discord. So let's see what I've got here. I've just got to go back in time a little bit. Oh yeah, this one. This is the S600, which is the new large one. And this is before, yeah, this is it sitting, you can see down in the bottom right, just near my face, that is the edge of where the roller door comes. So this was before before Princess Fiona and I cleaned up for the barbecue. We ended up packing up a whole bunch of stuff back here in the background, and all of this table got cleared, and then this machine got moved all the way down further back to clear the front area so we'd have space for the barbecue. And so it's a little bit hard to tell from here, but it is physically very large. You can see it's taking up the entire width essentially of the open area of the loading dock. And you can see there, that grey thing there, that slab that runs, that actually like fills the entire middle part of the machine, that is a big slab of granite, which is why this chassis weighs 880 kilos. Where's another photo of it? Oh yeah, this one, yes. So this is it on the forklift coming up the driveway. This was a couple of weeks ago now.
Not again.
Hang on, I just had to turn the volume up on that. What was that comment? Oh no, not again, says Pete. Oh yeah. You're
Admiral Waltep said, "Oh no, not again."
Oh no, not again. Said the pot plant. Was it a bowl of petunias to the whale? Yeah, so this is the KO being brought up the driveway on the forklift. There's also a new reflow oven. Do I have a photo of that? I may not. Oh, I do have a photo of it, but Princess Fiona is in that photo, so I'm not going to show that one. I don't think I've got any photos of it after it arrived here. No, I don't. I do not have photos of the new reflow oven or the new solder stencil printer. I've essentially got 2 complete pick and place production lines now worth of equipment, plus plus more if you count the other extra pick and place machines as spares. Yeah, I've got way too much equipment. Oh, what's this photo? Photos? Oh yeah, that's just the inside of machine 2, but no.
At Tinker001 said, "Run, take more pics, John."
Run, take more pics. Yeah. Good morning to Pete. Ingmam8858. Ingmam. Is that a different profile for the person we generally know as Iggy? Possibly. Stephen4479, Simon CBR, Guildco. Welcome everybody. Tech Nebulous is also here. What with all those machines? Yeah. Yeah. David said, "Whoa, you could move past a Sunday morning stream and make a go at this electronics lark." Yeah. Okay. So, yeah, same question every time, John. Yes, I know. It's because I know, Iggy. It's because my brain is broken. We all know that. Everybody here knows my brain is broken. It is very broken. Okay. So, yes, welcome. Okay, so I'm just looking at my little thing. Pick and place machines. So this, seriously, if you know of someone who wants to buy 1, 2, or 3 pick and place machines, please get in touch. Next. Yeah, a quick little update on Register. It's not broken, it's just different. Brain is, says David. Yeah, he says it's some dumb YouTube created auto name. This, yes, dashboard. I'm not going to spend too much time on this. Say $2. $2. Come on. Will it say it? We're about to find out if TTS will say it.
At Waltep said, $2.
Yes, $2. I have no idea what that means. Yeah, so this is the production management system that I kind of fell off sideways. I am on such a deep side quest with this because the whole point of this, where this all began, was to track boards and their test results so that what I could do is do testing of boards and have somewhere to store the outcome of it. Oop, expand. There's nothing there to expand. And then because Testomatic is a whole big thing. So the whole reason for doing this was as a place for storing test results out of Testomatic. And then the more I started thinking about enterprise resource planning and stock management and production, like planning batches and queuing orders and that sort of thing, I just realized how much scope there was to turn this system into a full production management system. Yes, good morning to Jack's Tech as well. Welcome. And so I've just kept adding features to it. Adding and adding and adding. So some of the things that I've done, I showed you a few things last week. But what you can see, for example, is, yeah, it manages all of the source files for the projects, bill of materials. It's got a bill of materials here for it. Figures out the cost. Oh, there's one there. What is that? Oh, it's a header. Okay, I haven't yet defined through hole and surface mount pins for that, and I don't have a price for it. So that's a part that I need to finish the definition of. It works out full bill of materials costing, kitting fees, additional bill of materials, which in this case is a 3D printed enclosure, tells me the total cost per unit. Consumables, so using up.
At John Dashwood said, going really well, 30 minutes in and minimal reference to today's subject.
Don't remind me of the subject. I might get onto it. Yeah, production consumables, so things like solder paste and power and all of those things that get used up in building these things. It's all in there. And we can do production batches. Production batches I have been using, and I'm going to click on it. It is going to show some client boards, but nothing too revealery that is going to get me in trouble. Yeah, so this is showing production status, the progress through all the different stages of production, and then this can turn into a dashboard. So there is a dashboard of this on a screen, visible in the lab, so that we can just glance across and go, oh yeah, that one is up to this stage, this one needs that. And you can click on one and it will take you to details for it.
One day, John will title a stream as Squirrel Hunting.
Squirrel hunting, yeah. So parts management is really extending. It's got all these categories because the number of parts in the system now, so it's around 300-ish, 304, whatever it is going to continue to grow. When all of these categories are open, this page just becomes ridiculously long, and scrolling through it takes ages. So I added collapsible categories. So the categories are always there, but now they are collapsible, and they show you how many there are within it. And then you can come into one of these, and like SS56, this is the version we were looking at before. I've added stock tracking, stock history tracking. Oh, this one is a broken one. This is actually exhibiting a bug because of the way it is tracking the stock on LCSC. I need to degroup these. Oh, I actually need to change the way it handles grouping on LCSC parts, because it's two SKUs with LCSC, but it's the same manufacturer SKU, and it is getting very confused, which is why it's doing that sawtooth thing. Other parts that don't have that issue, like and it's got type ahead search, and it opens categories dynamically as you match something. So if I type INA, you can see that it is matching on this because it says illuminated INA, and there is INA in these other things, and there's that voltage sensor down there. So if I do INA 260, it narrows it down to that. Come in here, and you can see stock level trends on this, and there are little spark charts in here as well. This is all new this week. So you can see the LCSC stock trend has gone down and then bounced back up again. So there are little trend spark charts here, and you can see that there is grouping on DigiKey. Yeah, you can see there's grouping on DigiKey because these are 3 different DigiKey SKUs for the same part number. And you can see the black line is the total stock across all suppliers. In this case, blue is DigiKey stock, and you can see it's updating every 24 hours. And down here is LCSC stock, and it's updating every 24 hours. Yeah, so we're tracking stock. It is also keeping a historical record of price. So it's pulling down price breaks for every supplier SKU, and all of that is being recorded historically as well. So what I can do over time is show availability trends for parts, and I can show price trends for parts as well. So if anything has major price fluctuations, we can flag that. That is all being recorded now in the system. So in fact, if in the repo, so if anybody wants to check this out, this is where it is. And Simon said, what is the SKU for a squirrel? That would be trending upwards. I have to put a squirrel in. I definitely have to put a squirrel in as an item. Like I can put it in. There's no miscellaneous, but I can put it in symbols, which just has like fiducials and yeah. So symbols are things that have no stock tracking, and because they are not they're not things that you have to stock. So they have infinite quantities available. So in here, if we're going to issues and closed, 59 closed issues. So just since the last stream, like if we look down here, where was it? Batch-based cost calculations was one I showed. I think that was what I showed last week. Since then, from here, so the bottom of the screen up, this is all new stuff that has been implemented since last week. So maintaining the historical part stock data, historical part cost data, displaying historical stock levels, done that. There is some URL handling stuff, subparts and supplemental parts. This is a big one. Hide delete icon in the parts list for, this is just a quality of life thing.
What if someone orders one?
What if someone orders a squirrel? Well, this is a totally internal system. This is a production management system. So nobody can order my parts. This is for tracking my internal parts. Allow parts list categories to be collapsed. That's done. Region-specific stuff. So this had some currency implications as well. So it's now properly handling Australian currency pricing from DigiKey through their API. Oh, this one's a fun one. Part value sorting that honors engineering nomenclature. Multiple SKUs for the same part and not consistently updated together. Fix that one. That was an API client improvement. Yeah, so this thing, this subparts, this thing. Now, this is an interesting thing. It was something that I did not, it took me a while to get my head around a possible way to solve this problem. And where is it? Subparts, supplemental parts. So this was my description of the problem. The basic problem is there are certain things that when you put them into a design...
At Tinker001 said, are you tracking when manufacturers suddenly say not for new designs on their data sheets?
Ah, yeah, so checking... yeah, there is a particular field which is whether in DigiKey say current or not current. I think is a binary flag in their API response. So if you have a look for a part on DigiKey, let's just come in here. Let's see what's in my cart on DigiKey. I don't even remember. Oh, no, okay. Products, let's do a search for, let's just go for diodes. Single diodes, rectifier. We'll pick up, oh yeah, see product status up here. No, sorry, it's not a binary, not a Boolean field, it's an actual status. So
at Tabrazem said, it's usually part life cycle.
Yeah, part life cycle, exactly. So yeah, obsolete, not for new designs, last time buy, discontinued DigiKey. These are all really, really bad. You don't want to be designing something into your product if it falls into one of those bottom four categories. So I almost always apply the active flag, like just by default. And you can see that it's dropped from 48,000 or 49,000 to 33,500 just by applying the active flag, which pushes out everything that's discontinued or not for new designs and those things. So yeah, at the moment I'm not doing anything with that data, but it is coming back in the response from the API. I could be using it, but I'm not. That is more something that I consider at the design stage. This is a production tool, not really a design tool. So this is taking the end result of the design of the project, whatever the board is, and helping me to assemble it. So this thing about subparts or supplemental parts, classic example is happening right now here in BeetleBot, because what we have is a failure to communicate. So this thing, F1, let's go to that. That is the part recommended. Where are we? OmniBlock. Yeah. It was Austin who recommended this one to me, and a couple of other people have mentioned it as well. So I apologize to the people who I have not named. And you can see that this is a fuse. So part number is F1. It comes out of the library Superhouse fuses. The footprint is OmniBlock, and its value is 1A or 1 amp. Now this is not it's an okay example. Actually, yeah, I'm just going to ignore that. It is a good example. Let's just pretend it's a good example. What this consists of is two things.
At Tinker001 said, I've seen 3 different parts go EOL in the past year. Made me a bit crazy.
Yeah, and the thing is that we're actually going through a little bit of a another chipocalypse right now, which a lot of people aren't even aware of, but it's bitten me a number of times. We had that big chipocalypse back around 2020 to 2022 region, and then things started to recover a bit since then. So we've had a couple of years now where we've got back into the mindset of you can just design things in. If a part is current, you can design it in and you can buy it when you want to go to production. But over the last couple of months, there have been a number of things that have just become unobtainium again. And not for any particular reason, like, not for the usual reasons, like this part has been deprecated, it's been end of life or whatever. No, they're things that are in full production, you just can't buy them. Connectors have been a problem recently. Deutsch connectors like the DTM 12PA 12PB, I think is the part number off the top of my head. And the, natural causes.
At Tinker001 said, 2020 was natural causes. Current issue is man-made.
Yeah, it is man-made. Yes, by a man. And, well, a confluence of men. Yep, it is becoming a problem. There are certain things. There are 2 production batches that I've had recently that I have not been able to run because of inability to buy parts. So a couple of connectors have been really bad, but a couple of ICs as well. Things that normally, motor drivers, some motor drivers have started to become bad again. Motor drivers just vanished during the first chipocalypse. And they're not too bad now, but you've got to actually pay attention. It's more of an issue. Anyway, point being, fuses. When you spec a fuse to go into a product, what you are actually speccing is not 1, but 2 things. There is the fuse holder that goes on the PCB, and there is the fuse that goes in the fuse holder. So in this case, we've got the fuse here, and if we have a look on the assembly, and it stopped working again. Last week I was ranting about the Space Mouse being broken in Fusion, and then I got it all working again, and now I've been using it all week, and now I've just tried to open it and it's broken again. What? No, I'm going to resist it. I'm going to not get into a rage quit situation. I am not. Okay, fuse here. So there is the fuse base, and then there is the fuse that goes into it. Now the thing is, the fuse base is common regardless of what value fuse you put in it. And so you may have stock, you might have a whole bag or a reel or whatever form of the fuse bases to put on, and then you might have multiple bags or whatever form of the fuses that go into them. And you need to track their stock individually. So what the problem that I was facing was how to handle that. And the way that I was doing it inside ERP, or the register, was that I had different fuse. It's not this way now. What I did have was mini blade fuse holder 1 amp, mini blade fuse holder 2 amp, mini blade fuse holder 5 amp. And what that represented was the fuse holder plus the fuse. But the problem is that that then conflates the stock of the fuse holder and the fuses. You might have plenty of fuse holders and run out of a particular value of fuse. And also it means that you end up with multiple stock entries that are all backed by the same stock. It's just not a really good model. It doesn't map reality into the data model very well of the software. So what I did was, Owen Simon says, that is similar to connectors that have various types of pins. Yes, and also another scenario is pin headers with jumpers on them. You need to have stock for the pin headers and you need stock for the jumpers. And the jumpers might be different colors instead of different values. So what I did was, so this is describing the basic problem. And so what I came up with was the idea of using the bill of materials filters and applying it. So if I come over to settings and we've got part import filters, what we had before was 3 sets of rules starting here. So the first was, this was number 1. So we had exclusion rules, then transformation rules, and then library settings. And they did 3 different things. It's a lot like firewall rules, where you import an entry from a design and it passes down through all of these rules like filters and then gets to the far end, and it either gets dropped entirely, so exclusion rules just drops these. If something is in a bill of materials and the device is SJ or SJC, it just gets dropped. It never passes through, it never appears in your actual bill of materials, it never gets created as a part in the database. So that's like a hard reject rule. And that's because SJ and SJC, in this if it's in this library and it has that device, it's a solderable jumper on the PCB. It's just a feature of the copper on the PCB. There is no part, it doesn't exist. So even though it is a part in the context of the schematic and the feature on the PCB, you never need to track it, you never need to care about it. So it just gets hard excluded. Transformation rules allow you to map one thing to another. So the first one, for example, is if you have an 0603 capacitor in the design and the value in the design says 100 nanofarad 50 volt, it gets remapped to just say 100 nanofarad. So that's a way of doing things like normalizing part definitions so that they fall out the bottom of the filters, all formatted the same way. And for example, a 4U7 cap, if it is in a 1206 footprint, but not in any other footprint, gets remapped so that it says 4.7 100 volt. So it gets mapped from 4U7 to 4.7 UF 100 volt. So yeah, anyway, all of these transformation rules take care of normalizing data. And then library settings just means that if something is in this library, then you can ignore one of these attributes. And the common one is ignore value. So if it's a switch, you ignore the value because switches have different values. In the schematic, you might say this switch, the value is mode, and this switch, the value is power. They're the exact same switch. You don't want to create multiple entries in your parts library just because they have the switch has different values. It's the same switch. So just ignore the value, and that drops that is like an exclusion filter on the value, but it then passes through to the rest of the processing. So this was my solution. I added supplemental part rules to the top. So the very first thing that happens is when you're importing a bill of materials, if it comes across something that matches the rules that you define here, it creates a supplemental part. And if we look at this bottom one, so if the library is Superhouse fuses and the device is fuse and the package is MCCQ, which is a mini blade fuse holder, then create a supplemental part. And the supplemental part is going to have its library set to supplements, it's going to have its device set to fuse, its package set to mini blade, and its value copied from the parent, and it's going to have a suffix of fuse added to it, which sounds confusing, but I'll show you what that means in a minute. Now, so this one, you can see the value is copied across, and then based on the final rule, fuses, the value is deleted from the original entry. It's not deleted from the supplemental entry, because the supplemental entry is now in the supplemental library. Sounds confusing, but the way that actually works out, if we come into designs, let's find one with a fuse in it. Does that? No, it does that. I've got to find one with a fuse in it that is safe for me to show. I wonder if Testomatic should have a fuse. I wonder if I've actually updated this. So if we come down to F, oh yeah, here we go. So we've got, and you can see here that there are some that this did not happen to. F3 is an MCCQ mini blade fuse holder. It has had its value deleted, and it has had this F3-fuse supplemental part added with 10 amp mini blade fuse. So the value has been passed across. It has no coordinates. It has no through hole or surface mount pads, because it is just a thing that gets added. It's got its own cost separate from the fuse holder, and it has its own stock that is tracked. So back in parts, if we have a look in fuses, you can see there is the mini blade fuse holder there, which has 37,310 available. The 10 amp mini blade fuse has 19,340 available. So now we can stock, so now we can actually legitimately track
So, if the part is a
multiple
squirrel
parts.
and the value is Steph, possible you might end up with supplemental offspring.
Maybe supplemental offspring. It could be. So yeah, anyway, that was a bit of a twisty one. The end result is really, really nice. I did not know at the start of the week, I did not know how I was going to solve that problem. And I sort of had it tumbling around inside my head for a while, and I wrote a couple of things down before I got to the point of defining the problem like this. And in defining it, the solution kind of fell out. And so now we've got this system where me explaining it, it sounds kind of complicated. But the end result is, if you go into a design and you import, so we go populate from BOM. In fact, I wonder if this one's been updated. Let's see, populate from BOM. 0 entries added, 27 skip, 0 excluded. Yeah, okay, it didn't need any updates. So you just go populate from BOM, it pulls the information out of the Fusion design, it fills in all of these, it matches references to the parts library, adds all of the costings and all of the joint requirements, applies all the rules, so it does the split, creates the supplementary parts, and the end result is that you end up with a bill of materials which actually represents what you need, all just by clicking that button. Yeah, so in practice, all of the thought that has gone into this process and making it work has made it really quick and easy to do the right thing. You just go populate from BOM, boom, and it happens. Oh yeah, and this was a fun thing a couple of days ago. So if we come into resistors, there is something that you will notice about this list. Well, maybe you won't notice. But the basic problem was, this is what I was mentioning before. So there is this issue where a 5,100 ohm resistor could be 5.1K, or it could be 5K1, or it could be 5,100, or whatever. So this was defining, once again, the problem, and the fact that sorting does not sort by value. It sorts doesn't sort by normalized value. It sorts by alphabetical. So 100K sorts before, so it's 100,000 ohms, sorts before 100 ohms, which sorts before 10,000 ohms, which sorts before 10 million ohms, it sorts before 10 ohms. So if you're trying to read this in a value of ascending order, it really doesn't make sense. It should sort like that. Anyway, I postulated a couple of ways to do it, and the end result is a conversion function that you pass the name through, and the conversion function understands the engineering notation and returns the list sorted by the normalized value. So if you look at this list now, you can see it's 0R, 10 ohms, 30 ohms, 47 ohms, 49.9 ohms, 100 ohms, 120 ohms. It is actually now all in value order. And you can scroll down this list and the value keeps incrementing. Whereas previously, like 8K2 would have sorted way back before, you get what I'm saying. It would all be out of order. But now it is all in order. 120K, 680K, 1M, 10M. And that, because that is done in a little helper function in Django, inside the app, that natural sorting, and it applies to capacitors as well. It understands that 18 picofarads sorts before 22 picofarads, before 470 picofarads, etc. So that now applies in other places. So if I pick a part, it doesn't matter what I pick, any of them. If there are a couple of drop downs here, so there are possible substitutions. If I click on that drop down, this list is grouped by category, and it is now also in natural sort order, or in normalized value sort order. So all of the resistors down here are, where are we? Resistors. Yeah, all the resistors down here are sorted in normalized value order. And that, now that helper function handles the normalized sorting, that can be applied anywhere through the system, which is really nice. What else? Oh yeah, updates. Anyway, lots of stuff. So all of this stuff happened just this week in updates to ERP. So yeah, it does really cool, fun stuff now. It's now really useful. Okay, so Grant said, I'm a few minutes behind. Normal solution to your fuse issue is to use multi-level bombs. Some multi-level bombs have produced a part which has an attribute to indicate that it is not stockable or only gets created as part of the higher level item. Yep. Okay. Yeah. Yes. Well, maybe not stockable, maybe stockable. That it could be either way with this system. Because this is all rules based, I could make it not stockable. Like I could just set the no stock required flag on it if I wanted to. So if I went into, say, a 10 amp fuse, I could just click no stock required and then it would show infinite stock available, but there is actually stock required and I do want to track it separately. Yeah, having it done through those these part import filters, all these rules, gives me all the flexibility I need to be able to create those supplemental parts, which works brilliantly. So yeah, so I only implemented that 5 days ago, according to when that issue was closed, and I've been using it this week and very happy with it. Michael says, nails make great fuses, never blow. Okay. Oh, Tinker says, I've seen 3 different parts go end of life in the past year, made me a bit crazy. Yeah. Oh, we're almost up to halfway through the stream, which means it's time to get onto the subject. Come on, John, get with it, get with the program. Okay. That. Oh yes, RepRap Micron. I am going to be getting back to some RepRap Micron. So as I mentioned last week, Vic has been quite sick recently, and he seems to now be getting, it's going to be a bit of a road for him, but he's now at the point of doing a little bit more, and besides, I'm a fair way behind. I could be doing a lot more even without relying on Vic, because his system, his RepRap Micron, is way more developed than mine. I need to
Squirrel, squirrel,
catch
squirrel,
up.
squirrel, squirrel.
Yeah, thanks, Tinker. I need to catch up to the assembly stage that he is up to. Yeah, so next week, which is, amazingly, next week is birthday Sunday. I'm going to be old next week. Older. Less young, I don't know, one of those. More decrepit. Next week, next Sunday, I will, not 100% sure, but I will probably be RepRap Microning next Sunday. So, did I add this to my cart? Yes, I did. That's right. That's why I got to it. It's sitting there in my cart, ready to order. All right, I'm going to leave that for future stuff. Now, upshot of all of that is I spent so much time faffing around last week that I didn't actually do anything useful. So, I want to do something useful right now. Let's finish the assignments of pins to the Vroom 32. You can see that it's got essentially nothing hanging off it right now. It's got ground power and it's got the USB connections going to the hub, the USB hub. Doesn't even have enable or boot mode or anything on this. So I need to hook all of those up. I also need to hook up the pins that are going to be driving the H-bridges, because the H-bridges are sitting here looking very sad and lonely without a net in sight. So that needs to be done, and then we can do a bit of jiggery pokery and yeah, actually, I've just made a decision, a fairly momentous decision, which is I am going to mount the ESP32 cam on an extra 2.5mm plastic spacer, and based a little on Andy's suggestion last Sunday when we were talking about this at the barbecue, angle the camera a little bit forward. So what I mean by that is this is the camera bracket that I glue on top of the ESP32 cam, and this is the assembly. This is what it looks like when the ESP32 cam has the camera, which is on a little ribbon cable, glued onto the front of this yellow 3D printed block so that the camera points directly forward. Now the thing is that this is vertical. This face here is perfectly vertical. I need it so that the camera doesn't quite see, like the edge of the camera just sees there. One thing that Andy pointed out is that we don't necessarily need to see high. What we could do is angle the camera forward just slightly so that it's looking more at the field of view is more focused on the horizon and the ground in front of it and a bit above it, because that's really what the BeetleBot is going to be interested in. So what I could probably do is bring this up a little higher and lean it slightly forward, only a few degrees. But basically if I brought the camera up maybe 2mm, probably back about 1mm, and then angle it slightly forward, looking slightly down, what I can do is use extra plastic spacing. So these pins that are coming down from the bottom of the ESP32 cam, they have the plastic shroud that is the classic thing that's on pin headers, which is 2.5mm high. Actually, technically 2.54, I think, because it's probably based on 0.1 inch. So what I have done for quite a number of projects in the past is where I wanted a little bit of extra spacing, I will get the plastic surrounds and cut it up and have just single little square blocks. So you push it onto the pins, and now you've got a double height. And you can actually buy pin headers like this. You can buy pin headers that are extended with multiple strips of plastic in them so that you've got more clearance above whatever you're plugging into. So what I'm going to do, the fundamental problem here is, see the parts under the board stick down below the plastic of the pin header, and that means I can't put parts here. So that...
If it can't see very high, then it can identify you when it becomes sentient and rebels.
Haha, true. Yeah, we can jump up on chairs and hide from the robots. So the problem is, because of my lack of space around here, I was wanting to put the USB hub directly under the ESP32 cam, which is going into these two headers. The problem is, my plan is to put it straight into the PCB and solder it permanently into place, because I can't afford the height of headers. I can afford a little bit of height, but I can't take it up so high that it goes into header sockets. And that means the combination of these parts that are on the PCB directly under it, and where is it? Where is it? Oh, it's off to the right. And the parts that are under the PCB here mean that they would interfere with each other. But if I put an extra little bit of plastic on this pin and then put it into the PCB, it means that I have room underneath, and I should be able to put parts directly under this on the board. So that is what I'm going to do. Yeah, so that was the decision that I just made right then while I was looking at this, because I don't think I can fit all of this in the gap around here. USB hub can go there. Yeah, that's all right. That's fine. Fine, I tells you. Yeah, Andy didn't like the idea of the
If you
USB
raise the
cable coming
camera
out the
too
front.
much, it is going to end up looking like a Mars rover.
Yeah, the camera can't be raised too much because it's constrained by the top plate. There is, it's not actually visible here, but there is another plate that fits flat on top of this and provides the platform for add-ons that go on top of the bot. So we can't come up too high. We need the clearance
At John Dashwib
above
said,
this.
are you still planning on an arm?
Yes, that's right. So the arm will sit on top of the top plate. Yeah, so there are a couple of things that need to be added to this. One is, need to finalize the position of the USB socket. You can see that this 3D model has not been updated since the PCB was updated. You can see the USB socket is in the back right corner, and the fuse is in the back left. Oops, there. The decoupling caps are in the top right, the front right, and I'm going to put the regulator circuit down here in the right as well. So I want to move all of the power related stuff to the right hand side, which includes the connector for the battery, the fuse, power switch. I want that all on the right hand side, and then USB I can move back onto this side. Well, back onto it? It's never been on that side. Yeah, I was thinking of having the fuse there, the power switch there where the USB socket is, and move the USB socket up the front, up to here. Because the thing is that you only ever use the USB socket when you are programming it. It's not a thing that you normally plug in. Andy doesn't like the idea of having it up here, and I'm not crazy about it either, but I think it does make the most sense of all of the bad options. And the other thing is that we still need a riser. So we need pins that are going to pass through from the S3, coming up through some kind of a vertical interconnect, which is going to go to the top panel, and that is where extra things can be plugged in. So we need like a row of pin headers or something else which is going to take some I/O power and I/O up to the top so that it can then be exposed on the top plate for the arm or a LiDAR or whatever other actuator or sensors and things that you might want to add to it. So I should probably make myself a note, shouldn't I? To do, link H bridges to ESP32, add battery connection, yes. Add I/O connections for ISO top plate, yes. Power switch, yes. Perhaps a sub, no, we decided against that. So let's do a little update in here and then start with mapping some I/O for linking H bridges to ESP32, add battery connection. Battery connection I've already done. So that can disappear. It's not the best battery connection, but it is there. Add I/O connections for ISO top plate, yep. And that is going to be dependent on H bridges to ESP32. Once we see what, I wonder if, do we have a spare outlet on the USB hub? I hope we do. Spare, yes, okay. I'm going to pass, that's right. I know I am relearning things that I've already figured out. I'm going to pass USB port 3 up to the top plate as well, so that if you have an accessory that you want to add on the top plate, you can make use of USB to connect to that, which might, yeah, I don't know what it would be, but anyway, just in case. Like you might have a sub-processor and you want to be able to flash it through the USB connection. Okay, here's a question. Actually, this is something that, waiting for reservations. Don't do this. Fusion. I do not want to end up in another ranty thing where I am just angry at Autodesk because things are broken. Okay. Save. This is how, yeah. Waiting for reservations. What the hell is this crap? One or more designs in this assembly need to be reserved before this assembly can be saved. This shouldn't take long. If you prefer to return to your assembly without saving, click cancel. Yeah, and it'll just sit there and never actually do anything. And then you got to cancel, and then you quit, and then you end up with a broken.
The answer is yes if the money's right.
And then you end up with a broken design like we had last week. So I'm going to pull this, which is going to at least refresh one of the dependent designs, because this is dependent on the PCB. So I'm going to refresh that and save it, and then I'm going to close it. I'm going to close everything that I don't actually need to reduce it to the bare minimum. So Fusion, now you have a PCB open, you have a schematic open, and you have the project. Now, save it. Save it. Just do it. Don't complain. Okay, maybe now it's going to do it. Fighting the tools, fighting the tools. Tools that are too clever for themselves. Okay, so where were we? We were at this power switch. Yeah, so power switch is going to be that one that Grant suggested, but I will get to that. What's more important right now is getting all of the I/O mapped out. Oh yes, that's right, that's right. I was going to ask you something. I wanted some inspiration, some ideas for, what was it? I don't even remember. It was before I started ranting. I want... come on. Think, brain, think. We've got this. Must be a sunny day. Cloud is failing. Simon said, did someone install FreeCAD and KiCad for John?
Must be a sunny day. Cloud is failing.
4G modem, so your robot can leave the house. Yeah. Simon said, how much space will that actually give you? CAD can measure that difference between the ESP32 can and the bottom of the plastic of the pin headers. You won't get the full 2.54 millimeters. Yeah, that's true. I won't get the full 2.54. I may even end up bringing it up slightly higher than the 2.54. If I put some other kind of, I mean, ideally I would put sockets in there and then make the camera pluggable, the ESP32 cam board pluggable. I don't actually want to solder it in place because that's kind of annoying. I would rather have it replaceable so you can unplug it, you can flash it separately, etc. But we're kind of physically constrained here. So I could either maybe go for low profile headers, or I could go for some kind of an intermediate plastic spacer where I add perhaps 3.5 millimeters to that gap, which gives me enough room for the clearance from the can of the ESP down to parts that are on the board, like the USB hub, which is directly below it. Which will be lower than the 0603 parts around it, so there won't be a shorting risk of the metal can on the ESP sitting on top of the USB hub chip. All of the surrounding parts will be physically lower. Now, what was I going to do? I was talking about something, and I was going to ask you to, because I had really good suggestions last week, and I often get good suggestions, I was going to ask for someone to find me something. Now, what was it going to be? Ah, yes, I remember. Okay, now this, if we can figure this out, this would be a really nice thing for other projects as well. I have an idea for something that I would like to standardize on, and that is magnetic USB connection. So you get these sorts of things for charging phones, MagniLink, magnetic charging cables. But they don't really seem to be that standardized. And I would really like to figure out if, not certified, mixed opinions, are magnetic USB cables any good? What I would really like to do is find a particular style of magnetic USB connector that I can just use on different projects. So these things typically are a part that you plug into an existing USB socket. So maybe that is, I don't know. Maybe I should just start using those. What I was, the truth about magnetic USB cables are not recommended. Okay. What I was wanting, ideally, is something equivalent to the socket side of this, but that connects directly to the PCB, so that I don't have to put down a USB-C socket and then plug something into it. I just want like a magnetic pogo pin connector that goes directly onto the PCB. Stephen said, simple solution is to learn how to break physics and have multiple objects occupy the same space to solve your design problems. Yeah. Oh, that reminds me. Way back in the early days, the game engine behind Marathon, specifically the game engine used in Marathon 2, had a really weird quirk where it had no concept of things occupying the same space. And so it was actually possible to design maps for it where you could have a corridor that would, say, go a corridor, move down a bit, turn left, move down a bit, turn left, move down a bit, and then turn left again and pass through the original corridor, and the two of them would occupy the same physical space and not interact in any way. So you could make, there were some crazy maps around that were 4D space and totally brain-bending. Really, really fun. But it's funny when you look at a map. So you'd go in, you'd have the map view in the game. It shows you your location and the things you've seen so far. You know, the classic old style map, which you don't see in games that much anymore. And you'd be passing through areas that show you should be right next to someone else, and they wouldn't be there. And it's because they were in a different dimension within the same physical space. Yeah, Jack said non-Euclidean geometry. The Halo games did that too. Yeah, and John Whip says Escher game space. Yeah. Tinker says every magnetic USB connector I've ever tried stuck out annoyingly. Yep. Yeah. I would like a solution to this. What I want is something equivalent to the to Apple MagSafe chargers, but for USB. Ideally with a socket. So if I have a look for magnetic pogo pins, these things are really cool, but they don't really quite solve the problem. I have some of these. They are groovy. Oh, 3-pin right angle pair. Yeah, so this sort of thing is what I am wanting. I have used these, not this particular type. I've used a 2-pin. I've used round ones for magnetic charging connections on a project years ago, and they were really cool. You just like snap the cable on and it would charge and you could just pull it off. Really nice. But I want power and USB. So just data, D plus, D minus. I don't care about all the USB-C type compatibility. This one, for example, has right angle pins. So you solder this onto the PCB and then the other side snaps onto it and can be pulled off. I want that for USB. So, always upside down, says Michael. They are always upside down. But the problem is you can't just grab a standard 4-way magnetic pogo pin because it'll, oh yeah, these sorts of things. These are cool. Round. Let's see, or round, circular. Yeah, this sort of thing. You see how there is a disc, 3-pin, where's 4-pin? Okay, 4-pin. This is the sort of thing I want. So it's got the, it's got a big metal case around it, and then it's got concentric circles around a central point, and then the pogo has the central pin, and then it has other pins. So rotation doesn't matter. You just snap it on, and you get 4 connections, and the connections, because it's concentric circles, you know pin 1, 2, 3, 4, and you can get the polarity correct on D plus, D minus, and ground and V in and that sort of thing every time. So what I would really like is something like this, where one end of it is a cable with a USB-C or USB-A plug on the other end, so that I could have the socket in whichever way around. I don't know which way you would consider it. Either the contacts or the pogo pins would go on the device, and then you could have cables that just snap onto it. If I could find something decent like that, Stephen says, if you make the PCB 0.6mm thick, you can use a socketless USB-C port. Yeah, I've done that with USB-A, with the design of the Leo stick. Let's see if, yeah, this one. So this, oh, it's still listed at JCar as unavailable. Yeah, they haven't sold it for years. So this was the board I designed for LCA in Ballarat all of those years ago. I didn't, no, that's not quite stating it correctly. I didn't design it for LCA Ballarat. I designed it in time for LCA Ballarat, and then we gave away 600 of them at the conference. So everybody at the conference got one of these. And that is the USB-A connector formed with ENIG, so that's gold surface contacts on the PCB on a 0.6mm PCB. Was it 0.6? No, not 0.6. It was one. It was thicker than normal. It wasn't a 1.6mm PCB. It was a 2mm PCB. That's right. So for USB-A, you need a 2mm, I think it was 2, PCB to get the correct thickness to slide into the socket. So you could plug this PCB directly into the side of your laptop and talk to it and have I/O pins and everything available from your laptop, which is super cool. Really nice little boards, the size of a USB memory stick. So yeah, I've done that sort of thing before. Okay, this.
At Tinker001 said 2.5 millimeters for A.
2.5? Okay, thanks. Yeah, I couldn't remember. I designed that back in 2010 or something. It's been a minute. So this, or what year? I don't remember. Anyway, it was a decade and a half, give or take. So this cable is, I just pulled this morning out of my box of USB A to C cables. This is my very last USB A to C cable that I bought from IKEA because I thought IKEA is a place where you can consistently get the same thing long term. If you need more, you can get them. I bought, I don't know, 30 or 50 or something of these a couple of years ago, and I have now run out, and IKEA no longer sell USB A to C cables in yellow. So I'm in I've color coded all of my USB cables. A to micro is grey, A to C is yellow, C to C is blue, C to micro is black, and I've got dozens and dozens of them, and they're all color coded, so I can just grab the right USB cable. And I'm in the situation now where I am probably going to have to buy like 50 USB cables to replace the whole current stock of that particular type in order to have consistent color coding, because it would drive me crazy to have inconsistent color coding. Heat shrink fixes that problem. Okay. So I have a bunch of USB lights done that way. Yeah, says Tinker. Yeah, cool. Handy for sticking into the backs of servers. Yep. So you can do things like turn on the light on the server you're trying to find in the rack, which is, it's often a remarkably annoying thing, and it's easy to get wrong. You walk from one side of the rack around to the other side, and you're looking at the stack and you're trying to count from the top. Now, which one of those? Which one was I looking at?
Grant Meisel said, I think I have found the USB cable.
Ooh, Grant, please, tell me. Yeah, so what I want is a magnetic USB cable that I can standardize on to use in my projects. It would be great, particularly for a project like this, which is a robot, because you could do things like have it sitting on the ground plugged into the USB cable, and if you kick it or you stand up with your laptop or the robot, you tell the robot to drive away, it's not going to get hung up because its USB cable is trapping it like an anchor. It'll pop off and it'll be fine. Tinker says, oh, lighting for seeing where the heck I'm plugging things in, really. My servers all have blinky locator lights built in. Right, okay, so the blinky locator thing is not the problem. It's just physically being able to see inside the back of the rack. That can be a problem too, yes. Grant, I would say I'm holding my breath, but the evidence is that I'm not. John says, I had a set of leads that had the concentric circular connector with a knuckle joint at one end and different types of USB adapter at the other end, but all the magnets crumbled after snapping too often. Oh, okay. That's no good. Yeah, so what I want is something like this with a USB cable hanging off one of them. And also, I want recommendations for, okay, IKEA USB, you can see it's in my search history. IKEA USB cable, cables and chargers. Look at what they've done. That's not chargers, wireless, yeah. Okay, I'm going to say USB chargers even though they're not chargers, they're cables. So they've got what they have done is dramatically cut their range. If you go into IKEA now to buy USB cables, there are like 6. That's all you can get. They used to have all the different combinations of ends, and in all different colors. So there were many, many options. So I can see why they've rationalized, and different lengths. So I understand why they've rationalized it. But now, for example, if you want to buy USB-A to USB-C, you can only get it in lilac, like purple. So that is the equivalent of this one I've got here in yellow. I want to buy that same cable, that Sitbrun USB-A to USB-C, 1 meter in yellow. This is what I want to buy. And they've just stopped selling them. So that means I've probably got to go out and buy 50 of the lilac ones just to have consistent color coding across all of my workbenches and equipment and bits and pieces. And USB-C to C is only available in white now. I've standardized on blue for that. I have Sitbrun USB-C to USB-C in like a dark blue color. I've got a bunch of those. USB-A to USB-C. Oh, they got blue-orange 1.5 meter. That's a weird looking one. And then A to Lightning, dark red-brown. C to Lightning. And that's it. I think that is the sum total of the cables they sell. So you can't even get the micro cables anymore. I've got the grey ones here, which are the A to micro. They have gone. Yeah. So what I need is a source of high quality USB cables that I can just have I can bulk stock them so that every cable in my lab is color coded and they are all consistent. Magnetic mechanics lights, magnet to the rack wall or wall door. Yeah, that's really nice. Okay, URL in chat. The connector seems to be through hole. In chat, where is it in chat? Is it in this chat, or are you talking about in Discord or Facebook or where is my Discord? No, it doesn't look like it's in Discord.
Tinker001 said, spray cans of plastic dye, then buy white cables.
White cables, yeah. Anchor are my go-to cables, says John. Yeah, Anchor make decent stuff. I've got Anchor battery packs and various things. Grant isn't a mod, so I can't paste links in here. Why is Grant... Hang on, isn't Grant a mod? I thought Grant was a mod. Let's see. Add as moderator.
Grant Muzzle said, in case the chat blocked the URL, I also emailed it.
Oh, okay. I have just made you a mod, Grant. So, let me find the...
I'm switching my set to all USB-C and using adapters for everything that uses another protocol.
Yeah, okay, that is a good approach. Crispian says, I'm switching everything to USB-C and using adapters for anything that's oddball. Yeah. That way all the cables are the same and you just have different adapters. That's not a bad idea. Okay, so this is what Grant sent through. How does this handle reversing? Given that, is it like opposite polarity magnet so you can't plug it in the wrong way? My guess is that's what it is. Oh yeah, there we go, north and south. So it's got polarity matching, which means the cable is going to magnetically try to orient itself to snap on the correct way. And it will repel if you try to put it on the wrong way. So that's got a right angle, and that is straight, so cables that for bulkhead mounting with flying leads coming off them, and then you could connect them. Interesting. Let's see. White straight, white right angle. Oh yeah, it's straight in terms of the receptacle, not the cable. So black. Do we have something coming from USB-C for this? And how universal is this? Is this like a one-off thing where people are going to have? Yes. indecision. Indecision. I don't like the idea of putting a connector on there that can only be used with some special cable that people may not have. And that is where the pluggable magnetic ones are actually better, because you can plug the little magnetic receptacle into the receiving socket and use your magnetic cable, or you can unplug it and use a regular cable. Okay, I think I am coming to the conclusion that for this particular project, I don't want to lock people into using a special cable, because special cables suck. On the occasions that I've had products that use special cables, so USB on one end to something else on the other end, it's just something else that you can lose, and you can't go down to your local Office Works or wherever and just buy another cable. Okay, I like this, but I like this, but I think I'm talking myself into just sticking to standard USB-C. Grain says, no warranty, just found from a 5-minute search. Alternative is to have a recessed USB-C socket for the pluggable version. Yeah. Oh, Stephen says, yep, north-south magnets. These are used on the WizMesh.
At Tinker001 said, all the magnetic connectors you've brought up so far are also huge.
Yeah, that's true. They're pretty large. So Stephen was saying they're used on the Meshtastic tags and other things, common for smartwatches, etc. Plenty of generic supply of cables. Yeah, smartwatches, that's right. So things like charging cables for watches, for smartwatches, those custom cables are annoying. It'd be nice if there was, it would be nice if the USB consortium came out with a standardized design, a mechanical design for a magnetic version of a USB plug socket pair. But that has not happened. It is not going to happen. So we have what we have. We have to, you get what you get and you don't get upset. We've just got to work with what we have. All right, so upshot of all of that is I think I am going to stick with pluggable USB-C for now, and...
At John Dashwib said, and next week, how to nail jelly to the ceiling.
Yeah. Oh, it's so easy. You just stick it up there, you let go, you grab the nail, you put it in, you hammer it. Easy.
At Tinker001 said, think about how long it took them to finally come up with USB-C.
Yeah. And the problem is that USB-C has 22... Well, it doesn't actually have 22 signals in it. A USB-C plug and socket pair has 22 pins. Or is it 24? I think it might be 24. Yeah, not all of which are duplicated. Like, some of them are duplicated to allow rotation, some are not duplicated and are different on the different sides. So the actual signals is more like 16, I think. But yeah, doing 16 signals through a magnetic connector, like imagine one of these with 16 concentric circles in it. Yeah, it's just not practical. And what they would not do, I am pretty sure, is come out with a standard that is not compatible with the full USB-C functionality suite. So I only care about the 4 pins used in classic USB, which is ground, power, D+, D-. And a magnetic version of that in a standardized form would be my dream, but hasn't happened, not going to happen. I shouldn't waste time dreaming of what could be. I need to deal with what is, the reality of now. So let's do this. Let's assign, since it's it's already 11:35, let's assign some nets. how are we going to do this? I am going to... Oh, where is my raw power? V in plus. Okay, so I want to feed V in plus, and I'm going to take this. One of the things that has been highlighted out of all the work I've been doing with the register is the inconsistency in my design files. Because if I look at this ground symbol, for example, that is coming from Superhouse, the library, Superhouse supply symbols.
Tinker001 said, don't forget CC1 and CC2 in case you end up adding charging to the board.
Yeah, CC1 and CC2. That's right. Yes. Yes, I always do that anyway. In fact, I think it might already be on there. Where is it? Where's the USB socket? Yeah, there we go. CC1, CC2. Both pulled to ground through 5K1s for 500 milliamp request at 5 volts from the host. So anyway, this symbol is from the Superhouse Supply Symbols library, which is good, which is the current one. And it's been kind of funny as I've been importing bills of material, importing projects into the register, and it's been pulling all of the parts out of the design files and then populating them to match them up to existing parts in the library of parts. I've been finding all of these parts, all of these projects where I've used footprints or symbols from old libraries that I don't even use anymore, and they've been carried through because a particular block of a schematic was copied, like forward copied into a different project or something like that happened. And so I've got all of these things like ground and supply symbols that VM, that is going to be, I'm going to bring it up this way because it's an input. Yeah, it's got all of these symbols which have been carried forward, and they're things like from Freetronics libraries that I did in Eagle 15 years ago. And the library references are long gone, and the symbols might vary slightly because I've updated them, but they just have the wrong metadata associated with them. So what was I going to, oh, this is going to be V in plus, isn't it? Yeah, so let's do that. Out, and we need motor connections. Do we have any connections for motors? I don't think we do. We don't have any. So yeah, these are the H bridges here and here. I need a way of connecting motors to it. The motors have flying leads. Let's stick a couple of, we'll make it really simple. I'm just going to add some 0.1 pitch connectors. So let's come and have a look in M02. I'm going to use the classic style, which are the little oriented, what are they called? Yeah, the KF series, KF 2510. I'm going to use a couple of these because they are polarized. They're 0.1 inch pitch, which means we can just put pin headers in them if we feel like it. They're very common sort of thing. Different version, yes. Update, yes, do it. Okay. Pin 1, yeah, that'll do. In fact, I'm going to stick one over here while I'm thinking about it. Oops.
Wireless motor connections.
Well, yes, wireless motor connections. We'll just have like a little inductive link to it. How about we do that? Let's stick the output there. P-ground. P-ground on these, I'm pretty sure we have to link to regular ground. iLim. iLim, I think I pull to ground. I'm going to check that. So iLim is on this particular motor driver, the DIV8871, and there's also a 72. There are several different motor drivers in this family that are all in the same footprint. They're just SOP8, HSOP, and they have slightly varying features. In terms of the control, they work the same way, but they have slightly differing features. And one of them, I can't remember if it's the 71 or the 72, has current limiting this pin. So pin 4 can either be an input pin to the driver, which tells it its current limit, or it can be like an alert output. So if it hits the current limit, it'll assert it as an output, and then you can read it from your microcontroller for a stall detection or whatever you want to do. And I just universal. But the thing is that if you drive it if you use it as an output, and you don't care about it, you're not connected to it. It doesn't matter if it's got a pull down resistor on it. I can't remember the value of the pull down. I'm gonna look this up in a little bit. So if we have a look at, let's just stick a resistor on it. Resistor 0603 will do. Wait, yep. So we're going to stick a pull down on it, and I'm going to look up the value in a moment. I've got that value in another project. Let's move this down here, make it a little bit nicely aligned on the ground reference. Then, what am I doing? What I am doing is, do I need pull downs on these? I probably should. In 1 and 2, yeah, let's do it. I'm gonna add pull downs on the 2 inputs to the H bridge. Make these 10K because they'll be overridden by the outputs. The purpose of this is just that when the system powers up, when the micro is not driving the H bridges, we want them to default to off. So we don't get any movement of the robot on power up, regardless of what the microcontroller is doing. So unless the micro is actively driving those pins, we want this H bridge to be off, so the motor does not move. So now we need to figure out assigning those pins and the value of this. So I'm going to set a value of, dunno, for that one, and then I will figure it out. And let's link this. Come on, out here. Bring you out to about, about there. That'll do. Stick this in here, and we also have to do probably, okay, no, I've got to do this first. So my first order of business is assigning pins for the H bridges, and then I'm going to figure out what pins are left on the S3 and pick some useful ones to bring up on the riser. Where do I want that? How much space? That'll do. Yeah, that's nice. And then move that up. Link that. And I'm going to copy another 10K there and another one here. Come on. No, not group. I want move tool, move that. Move it. Not move the designator. That's what I wanted to move. And then stick another couple of grounds in here. Throw in some nets. And whoop. Joink. Yeah, that'll do. Put some flags on here and up there, and rename that to VIN. Got to attach that to the main power input. Okay, so we've got, what are we going to say? Call this left. Should we change the value on this? No, I'm going to change the value on this and make it L motor. And I'll make this one R motor. And then these nets, these will get renamed soon. But I'm just going, for now, I'm going to go IOX, and it is going to be L in 1. Yeah, just figuring out my naming convention. IOX L in 2. And then I'm going to match these up to IO pin. So IOX R in 1 and AOX R in 2. Okay, so later, and by later I mean like 1 minute from now, we are going to assign some I/O pins on the S3 to talk to those H bridges. So that's left, that's right. I don't even know if I've got the motor controllers on in the correct location right now. So let's figure that out. We can do that by looking at this. This one has a value of, where's the value? R motor, so it goes over here. Okay, so that one is the right, and this one is the left. And I'll spin it around, maybe spin it to about there, give or take. We'll see what the mechanical alignment shows in a minute. I think it's going to have to come in that way a little bit. I can't remember what the cavity is here. This wall is a couple of millimeters. It's at least a couple of millimeters thick, so this might still be too far out, or too far in rather, and I don't know if it's going to clear the back of the motor. So we will figure that out in a minute when we start messing around with the, when we start messing around with the, let's have a look now. Stuff it, save that, and then we're going to throw to 3D view and see where those connectors ended up. And pull. Sink it, baby. Okay, should give us some connectors in this sort of area. There we go. So we've got, the 3D model for that connector is broken. It's the zero, like its z-axis value is really offset. Woo, got to fix that. Okay, I don't know what's going on with that. Now, if we bring in, what I need to do is go to the assembly, because that's got the plastics in it. What would be nice would be if I drew the outline of the cavities exposed by the plastic on the PCB. Now I'll pull that and we'll see where it ends up.
At Tinker001 said, have you even tried to calculate the total usable area on the board, John?
I have not. Okay, so it looks like it needs to come, maybe I should put it here. It's going to be awkward to get fingers in, but I think it'll be workable. I think I'm going to rotate them 90 degrees and put them here, right next to the H bridge on each side. Let's go with that. So here, for example, this one would rotate that way and put it right close to the H bridge. And this one, same thing, but on the opposite side, which means it might even be useful to spin this H bridge, spin it that away. Oh, can this come out more? How much room do I have there? How close are the pins to the plastic? Ooh, there's a little bit of a gap. I could probably bring it a millimeter or so. Yeah, I can. I can bring that across. That gives me more clearance. That's nice. Okay, so I can bring this in this way and that in there. That one is already in that location, and I can bring this right up close. So let's see where that all falls on the spectrum of things. So pull the latest models off the PCB. So now we've got the connector next to the H bridge, just towards the outside. Might even be better to have it the other way around, have the connector on the inside and the H bridge on the out. But that's a minor detail that can be fixed. Yeah, we'll pull it in this view and see where it all fits together. Because my main concern here, discard, yeah, okay, discard an update. Yeah, my main concern here, don't move that, stop that. My main concern here is just being able to get your fingers into this cavity to plug that cable in. And also there is a little bit of stuff that sticks off the back of this motor. This 3D model does not show the solder terminals that the motor wires connect to. So there's a little bit that comes off the back of the motor protruding into this cavity here. So I think what I should do is swap this and put the connector on the inside and the H-bridge on the outside, because the H-bridge is low and the connector is high. Yeah, I will. I'm gonna do it. Gonna do it. So I'm gonna stick that right about there, and then stick this as close as practical to there. So that one to right about there. Bring the H-bridge out here, which means I can spin this H-bridge again, and then I'm gonna have to spin this H-bridge again, just so that the output pins are directly adjacent to the motor connector. And I think that's gonna be good. All right. Oh yeah, and there are a few other supporting parts related to those. These parts can go, well, ideally one of them would go nearby. So the no value yet resistor, which one is that? What is this? Oh, come on, don't drop it. Come on, Fusion, I clicked it, don't drop it. So that's a 10K, that can go up near the top. What's this one? That is an unknown value one. So this one is between ground and N16. It could go, right, oh no, I've got to get traces to those. How much room do I have behind? I don't think I can put it here. I think what I might do is put it here, and I'm just going to have to wire it through, but that's okay. And likewise, what's this one? That's a 10K, so that can go up. What's this one? That's the question value. Oh, this one, yeah, this will work out well, because what I can do is put this one on the top, and the trace is just direct, and then this one I can put on the top, and the trace is through a wire. But at least there is symmetry in terms of the layout, symmetrical clearances, etc. So I think that is a good way to do it. Now, back to here. So I need to look up the value of the slew rate limit, or is it current limit? I think it's slew rate limit. Generally with these, like the DIV 8871s and 72s, I just drive them at maximum slew rate. Like, I'm not trying to tune these motors for anything in particular. I just want to drive them hard. So whatever the minimum value is, or whatever the value is that applies the highest slew rate, is what we want. Now, I'm going to get that out of a design that I did a little while ago for a client. So I'm pulling this off screen, and I'm going to go into a client project that I'm not going to reveal on stream. And I've got to find where it is. Oh yes, that's it. It is in, oh, come on, I should have moved stuff off into that one. Yeah, that'll do. Should be in this design. I'm pretty sure I used this same H-bridge in this client board that you can't see. So, yes I did. Very good. Now, where is the current limiting? Where is the setting for it? 15K. There we go. So pulling iLim to ground via 15K is the way to do it. All right. So back to here. So this, in fact, what I could do is I could make these others 15K as well for consistency. Not that it matters, because I keep 10Ks loaded. Let's go value on this 15K. I'm tempted. I think I will. I'm going 15K. So I'm going to use 15K on these pull downs, because I like consistency. I think that means that by law, I now must replace all other bias resistors on the board with 15K. Maybe. Do I even have any? I will need some, because I need some on the reset and mode pins for the S3. What else do I have here? No 15Ks there. What about in here? 5K ones. I've got there's a 10K on the USB reset with a 1 microfarad. That doesn't matter, that could be 15K. Could be, oh yeah, these are 15Ks on the data lines. So this is a little RC network on the, like a bit of filtering on the USB data lines. So as it stands, this is the only 10K resistor now in the project. So no, not that. Let's go 15K on that as well. Let's see if we can make it. No, not that. I want value. Yes. Let's see if we can make a project that doesn't have a single 15K resistor in it. I mean, a single 10K resistor in it, which would be a first. It's never happened in the history of electronics. So then, okay, now we need to assign some I/O pins to the S3 to drive those things, and we probably need also to expose a serial port, like a spare UART type situation. I have a vague recollection that there are some strapping pins somewhere in the low value here on the S3, but I can't remember what they are. Oh, TTS is being an idiot again? Maybe? Where? Let's see. I've got to find it amongst all of these. Oh, there's the stream. Where is TTS? Did I close it? I have a feeling I may have even closed the, let's see, cast note. I did. It's because I opened another window. Okay. I'm logging back into cast note. Streams, upcoming, current. What? It's not even listed as a stream. Oh, streaming now. There we go. There we go. Ooh, got a couple of new people in the chat too. VL Andrew, welcome. Hey Hosey, welcome. TTS is... okay, TTS should be back. Ooh, but there's a weird rendering thing going on with it. Let's see if this works.
At Tinker001 said, don't forget CC1 and CC2 in case you end up adding charging to the board.
Yep, okay, so that was from a while ago. Okay, I think TTS is working again. Now, where? Okay. Strapping pins. Are there any low number strapping pins? ESP32, S3 strapping pins. So it's 03, 45, 46. 03. Okay, so let's make sure that I do not I do not use those. What have we got? Symbols, supply symbols. I think that's where my NC symbol is. So what am I doing? 3, 0, 3, 45, 46. That sounds right. Yep. And IO0 as well. Okay, so, but IO0 we are explicitly going to bias. So I'm just going to bring these out and flag them so that come on, rotate. Thank you. Rotate. Thank you. So that I know that I can't use them. So I'm just going to go IO3 strap, etc. IO 44, 45 strap, 46 strap. And that just marks them as off limits for whatever else I'm doing. Oh yeah, so I should put the enable stuff in here as well, shouldn't I? We need a reset button. Do we need a reset button? I think we need a reset button. The only thing is that the reset button is not going to be accessible externally. Do we make an externally accessible reset button? Do we? This
Lunch.
is a decision point. Lunch, yes. Easiest approach is to route the board to the ESP and then just use the most appropriate I/O once it's routed, as the I/O mux is so flexible. Yeah, that's right. Yeah, so for the UARTs, I can map them in the ESP's multiplexer, like its I/O multiplexer, to almost any pins. But when I'm doing this process, what I do early on is exclude things. So step one is to exclude strapping pins, and then I go through and look at other things that I might want to specifically avoid, and just make sure that when I do select things, I'm not conflicting with bad stuff. All right. Now, I've got a sore throat. That's annoying and weird. Oh, there are 10K resistors there. Okay, we haven't managed to get away from 10K resistors fully. That's sad. Oh well. Okay. What is that one? 22 microfarad. That'll be an 0805 footprint associated with that, I think. Oh, there's 100 nanofarad there. Let's copy that one and stick it over. Why am I making this hard for myself? I'm trying to figure out how to make all of this fit, and I can just do this. Why limit myself? Okay, so we've got enable and IO0. So what I want to do is pull, not that, I want to copy that, please, thank you. And then I'm going to move that up to there for consistency, as you will see in just a moment. And then I'm going to stick that one there and stick another one over there. So I want to pull IO0 high to prevent it going to bootloader mode. Enable will be biased high, but it will be done through
Great Meisel said, you just put in a 10K resistor.
I know, because I copied it. Because I copied it from somewhere else. There is a 10K up here. So what I could do is change these to 15Ks. No, 10K is fine. It was just a weird quirk that I was thinking it would be funny to make a board with no 10K resistors on it. I don't actually have to do it. So I want to bias the enable pin to ground through boot up using this 1 microfarad capacitor, and then have it, in fact what I'll do is I'm going to move, just for the visuals, so that you can see that this is a little timing circuit with it's going to charge the 1 microfarad capacitor through the 10K resistor on power up and bring up the enable line at a certain time. So then we're going to take that to a reset switch. What are we going to use? Let's just use where are we, switches? I'm just going to use a simple little, okay, this is decision point. Do we make a reset button that is exposed on the outside of the plastics? I'm inclined to say yes. So what I'm going to do is go for, let's see if I can find, yeah, like, I know I often have a cough on streams. In fact, I need to cough now. But
At Tinker001 said, at least you're not putting in weird precision values with no reason. Like some chip makers in their ref designs.
You hear that weird echo? I think I actually have 2 cast notes running now. Like some chip makers in their reference designs, yeah, use some weird thing like put a 12.4K pull up on a reset pin. Why? Just pick the 10K that every single PCBA already has loaded in their pick and place machines. You know why it happens? It's because these people are theoretical. They don't they're not the ones who actually have to run the pick and place machines or load the reels or rationalize the bill of materials at production time or place the orders for the parts because they spec'd a 12.4K resistor when a 10K would have done or a 15K would have done. They are sitting in simulations.
Put the reset button on the front so it resets when a collision occurs.
I am actually going to put the reset button on the front, but I hadn't got to that yet. Yeah, they sit there running simulations, and the simulation tells them that their pull-up on their reset pin should be a 12.4K resistor for the optimal RC value based on the number of milliseconds rise time on the reset line. So they spec a 12.4K resistor when it could have been anything from like 4K to 30K and worked absolutely perfectly fine. So pick one that is going to make assembly easier, please. So this is what I'm going to do. Nobody at me. I'm going to put one of these on as the reset. And I'll just ground that. That is so I'm going to take the signal to there. I'm going to take that. That is the mounting lug. That is also going to go to ground. And I'll give that a value of reset. Yeah, that'll do. In fact, no, I'm going to give it a value of reset. No, it doesn't need to be that. It's not a net name, it's just a value on a part. So reset is what it will be. Now, let's change the value on that. Mini. Anyway, I'm going to leave it as is. That doesn't really matter that much. I might just pull it out though so that it's not overlapping visually against the ground pin and it's easier to read. Now, where are we? Okay, I think we are almost at the point where we can assign nets to the H bridges and to okay, so keeping in mind the suggestion to route based on physical proximity, what pins have we got here? So low number pins, so pins like 5, 6, we've got the strapping pin there on IO3. Ideally the H bridges, we will bring off these low level pins on the left side of the module, left side because it's rotated 90 degrees anti-clockwise, and then we should use the lowest numbers for the left H bridge and the higher numbers for the right H bridge. So let's do that. I'm going to use, and we also need to bring some I2C out. So what I could do is bring out, no, not route, I want to bring out a net. A net from that one, net from this one. I'm going to use 1 and 2 and then 4 and 5 for my H bridge connections. And I'm going to So I'm going to use IO1 and IO2 and then IO4 and IO5. Okay, so down on the H bridge sheet we can go IO1, excuse me if you didn't give me the tool, there we go. So this one, instead of being IOX, is going to be IO1, this one is going to be IO2, and this will nicely give, come on, IO2, this will IO2, this will nicely give us the routing where the tracks will come out of the bottom of the module and head quite directly, and then that's going to be 4 and 5, isn't it? Yep, IO4, IO5. And now, because those net names exist, when I come back here to name these nets, it'll autocomplete for me. IO1, there, yes, connect. IO2, yep, connect. IO3, IO4 rather, IO4, no, not 45, no, escape from that, I want this, that, I want this one to be, I hit the wrong thing, IO4 R1 and IO5. That'll only have one match. There we go. So we have H-bridge driver pins allocated, and if we come back to the PCB layout, now you can see those two pins there. Where is it? IO1, LLRR. Oh, okay. They're going down to those resistors because the resistors need to be moved. That is why that one goes to that side. That one, which side does this go to? That side? That side? I think that's right. Bias. Oh, this is right. Okay, so this is one of the right resistors, and that stays. That is one of the left resistors. Okay, back over here. And that one. So these are bias resistors on the. Where can I? Maybe I'll put them up here. Do I? Don't I? I'd rather have them down here. I would rather. So that is going to have to trace around there. Oh, I don't like this so much. Let's see. Anyway, I'm going to... Those are only going to ground. I can pull them into vias, so let's spin them the other way. I might have to swap their relative positions. So I'm going to drop vias off this side and take them through to here because these traces are going to head up that way. And that is going to come around. Oh, that's annoying. What I should do, what I am going to do, is relocate the H-bridge. I'm going to move it up a little bit so that I can tuck this bias resistor in behind it, and that then gives me a clear path to that net. And what happens over this side? Ooh, I think I'm going to do the same thing, because what it's going to do is force me to use a via on the bias resistor on that net, but that is better than dealing with it on the other two nets. So I'm going to stick these down here for now. Ba-doink-a-doink. Yeah. It's going to need a little bit of cleaning up, but ooh, yeah, the order is actually correct there, and the order is correct there. Very good. All right, I'm going to try to route that around the battery compartment though, because I don't want abrasion of mechanical abrasion of the battery running over the tops of those tracks. Or I might just drop them with vias and take them around the bottom, because I've got to bottom layer them anyway through to this, down this end. Okay, so this is the reset circuit. That is going to go somewhere, probably up here on one of these front corners, recessed. Okay, back to the schematic. So let's look at our to-do. Link H-bridges to ESP32. That we have now done. Get rid of that. Power switch. Okay, I've still got to add the power switch. I'm going to leave that in my to-do. It's got a little dog leg in the schematic so that I know where it goes. Add I/O connections for riser top plate. Okay, but the reason I'm not doing that right now is I need to make a footprint for wherever it is, that part that Grant sent me the link for. So add I/O connections for riser top plate. What happened then? Oh, okay. Is that being weird? Okay, so the connections for the riser top plate, what do we want to have? We're going to need ground. We need V in plus, because we want to pass up raw power in case some device on the top wants to use it. We also should pass through 5 volts, and we also should pass through, I believe, 3.3 volts, because all the I/O is 3.3. So we need 4 power connections, 4 power nets coming to the top plate. Then we need D plus, I'm just going to do it like this, D plus and D minus for the USB connection coming up to the riser. And then we need some general purpose I/O. Oh, we need I squared C. We will definitely take that up to the top plate. And, which means I've got to designate some I squared C pins. Then we need some GPIOs. And I don't know, 4, 6, basically as many as I can as many as I can do. So what have we got here? 4, 5, 6, 7, 8, plus 6, so 14 pins. Or if we did 4, then we've got somewhere in the region of 12 to 14 pins going from the bottom to the top plate, which is a lot. And then on the top plate, we can expose things like the little SAO connectors that Andy likes for putting simple add-ons. Ideally, we'd bring SPI up as well. Do we want to bring SPI up? Oh, another cough. Yeah, do we want to bring up SPI? Because that is a bunch more pins. Probably, I don't want to. I don't want to. Okay, what are we going to use for I squared C? Let's make it, I don't know, IO 6 and 7? Yeah, no? Any reason to not use IO 6 and 7? I don't think there isn't any particular reason to, and we'll make that 4K7 pull-ups on the I squared C. Pulling it up, so we've got 3.3 volt I squared C. Pulling that up, and we are going to bias those, and then we're going to put some flags on here. So,
At Grandfather said, work out how many pins you need to run the base module and bring everything else up to the top.
Bring everything else up to the top. Yeah, I should take everything. You're right. What I should do is expose everything possible. Let's make IO6 SDA, and we'll make IO7 clock. That will do. That will do, donkey. That will do. So then we've got Kopi, clock, Kipo over here. Let's expose this stuff just because we can. I'm going to name the nets anyway. I don't think this has a default, well, no, it does not have a default chip select pin for connecting to other peripherals, but we can just use any of the GPIOs. That sounds so good when it's in stereo like that. Double it, yes, echo. Yeah, I think I actually do have a second cast note running. So what's happening is that we are getting the same audio played twice, slightly offset. So that's going to be, so we've got I squared C over here. We have SPI over here. And then we want a bunch of GPIOs. Maybe I will just bring like a whole lot of these over. What else did I say? What did I have? So there are the 4 ground pins. Oh, and plus and minus, of course, coming off the USB hub. That's not off the S3. So we've got I squared C, and then we've got a bunch of GPIOs, and we've already got SPI. So let's expose some of these low-level pins. And then these low-level pins could also be used, low-number pins, could also be used for UARTs, because we can map a UART through the mux, the IO mux in the processor. 1, 2, 3, 4, 5, 6, 7. It's an odd number. I do not like odd numbers. What? you're you're just trying to mess with the TTS now, aren't you? Let's go. Let's just name these nets for posterity. IO9. I don't think there are any particular weirdnesses about these low-level IO pins on the S3 IO11. So we can arbitrarily use them for chip select on SPI. We can use them for, we could use them for an extra I2C bus if we wanted to. What's that one? IO13. We can use them for UARTs, IO14. Okay, and what's that pin at? 18 and 19. All right, I'm going to bring another one up. So let's see how many pins this ends up exposing. It's going to be way too many. And I don't know what connector to use. Maybe just like a double row pin header. That might be the simplest. What's this one? IO15. IO15. And then here we've got IO35 as Kopi, which is Mosi. And then we've got clock IO36, no, 36, SCK. And we've got IO37 as miso soup. Yeah, that all. I think that gives us all of the I/O that we would want to bring up. So, what does this come to now? So we've got 4 power plus 2.
Che, car.
Plus, yeah, this is going to be a very big riser connection, which is annoying, but oh well. So we've got, I wonder if it's better to have 2 risers, like one on each side. No. Let's see. We'll just put it on a connector and see how big it is. Let's find out what goes on here. So we've got 4 plus 2. So we've got 6, 7, 8, 9.
All the way home.
Oh, actually, there are 9 there. So if I drop one of the I/O pins, that will then even up the number again. So I'm going to drop IO15. 1, 2, 3, 4, 5, 6, 7. So that makes it 16. And then we've got USB, which makes it 18. That is a big connector. I don't like that. I might end up dropping a couple more of these I/O pins, but for now, let's stick a pin header in there, which is like a 2 by 8, and I'll just make it like a.
At Grant Price said, it is tempting to use 2mm pitch risers, but it would also be nice to be able to connect DuPont cables.
Yeah, that's right. 2mm pitch would be a lot nicer. So this is a 2 by 8 socket, and I think that is the right thing to do. Instead of having pins sticking up where the signals are exposed from the baseboard, if you don't have the top board plugged in, it means that there is a shorting danger on those. I think what I want to do is go for a 2 by 8 socket, and then the pins can be on the top board that locates down and plugs into it. So let's throw that into the mix and just see how that works out in practice. Oh, that is a big connector. If, for example, we wanted to stick it up here somewhere, and I'm probably going to have to relocate these. Yeah, that is not going to clear the front of the motor, I think. Possibly. So let's have a look at the mechanical issues here and maybe find some alternative location for that riser. Either that, or I make it 2 smaller risers and have them on each side, so make it symmetrical, and have so if we made it 2 8-way risers, we could have power, USB and I2C on one side, and then all GPIOs on the other. That might actually work out fairly nicely. So let's see what that looks like in the context of this with the plastic in the way. Update, update. Discard and update. Yes, just do it. Okay, yeah, so you can see that the connector in there. Let's do a section analysis. Inspect, no, not that. I want section analysis. So here we can see that it is intersecting with the front of the motor. But if I made it half as long, it should fit fairly nicely. Yeah, so let's do this. Let's go back to this, and instead of having a 16-way header, I'm going to have two 8-way headers. So let's go back to connectors, and it also gives me the 2x4. I wonder if I have a socket. Oh yeah, I do. Yep, okay. A 2x4, which gives me an 8-way, and I'm going to go left and right. And so instead of that 16-way, we're going to have one. Oh, there's the USB socket in the way. Let's try putting it. I'm going to bring it down. Let's look at that section analysis again. So I've got to. Hang on, where did the section analysis go? Oh, analysis. I had it turned off. Okay, so I need to bring it. Or maybe I could even rotate it. Oh, I don't know how much clearance there is around the front of that motor. If we bring, what's that section? Oh, that was a vertical section. So if I edit this section analysis and bring it up, where is the front of the motor? Okay, I want to bring the analysis to about there. Yep. Okay. So if it's going to be so tight, but tight is fine. If it fits, it sits. So I'm going to bring this up and squash it right about there or there. Let's go back to this section analysis again. Okay, it's got to be aligned with the third row. So it needs to be there. And how close are we on the left? It is intersecting, so it just comes in slightly. Okay, I think this is going to be super close. So that connector, I think, is going to be good. Let's move this one out of the way. And then if we do the same on both sides, hopefully it'll clear the front of the motor. So I need to check that there is a tab that sticks off the front of the motor as well, which is why we have that little alcove in there. And I need to make sure that it is going to clear that. Oh, stomach rumble. My stomach is telling me it's time to eat. Time to eat. Okay, that's better. So now, let's see where it falls into this cavity. And then I can extend this cavity forwards a little bit as well. That is probably a good idea. I do have room in there. Oh, look at this. Look at this. That is fitting like a glove.
0001 said, you really need a better 3D model of the motor.
Yeah, I do. I have an actual motor right here. I have one. Oops. In an enclosure. You're right, I do need a better 3D model of the motor. Oh, it's going to fit. I can tell by eyeballing it with my very own eyes right here. Look at this. It's going to fit. Oh, it's a little bit hard for you to see. Okay, let's go to overhead cam. TM. Overhead cam can go. Oh, except the overhead cam is not focused. That's all right, I can fix that. Overhead cam is there. And in fact, what I can do is zoom the overhead cam Set it like that. I'm going to zoom OHC and then focus it. There, that is what we are looking at. Get the focus on. It'll jump back out again in a second. It won't be that zoomed in. That's artificial software zoom for the zoom assist. Jonk, there it goes. Okay, so the cavity we are talking about is right here. And the connector will sit in that region. This is rotated 90 degrees. In fact, I'll rotate it the same as the, the design. So we can see there is a cavity here in the front of each motor, and there is this little tab sticking out of the front. That tab is not in my 3D model, so that is what the issue is. But there is actually plenty of room there for that connector to go in that space. So that, I believe that is the solution. In fact, I could bring it just slightly to the right to make it clear this corner better. I think that would work very nicely. And as you can see in the model here, it is currently butted hard up against the plastic of the left side of that cavity, and there's a little gap there. I want to bring it to the right by, I think, 1 millimeter. This is 2.54 millimeter pitch, so if I take it to the right 1 millimeter, it'll have just a nice amount of clearance around it. So I'm going to go from there to there, and then I'm going to put this one in the equivalent position on the other side, totally ignoring the USB-C connector for now because that is going to have to move. Is that the same gap? It looks like it is. So, and I don't know about rotation yet. I might have to flip them 180 degrees or something. But that, I think, will get us a long way there. So I'll delete that one. It's still hanging around. Yeah, so that's got the two. Hang on, why didn't that rotate? What is wrong with this picture? Is it? Did I not save that? Oh, it's just saying that it needs to be pulled. Again, I just pulled it. Synchronize. So that connector should rotate. Yep. And then if we come in here and synchronize, that connector should now jump down a little bit so it'll clear that left wall of the cavity. There we go. Look at that. It's a thing of beauty. And it just clears the top wall of the cavity there. It's got a little bit of room. It's sort of centered in the end. And if we bring it across, if we come across to this side, we can see the other one is in this cavity. Okay, so that gives us two risers which can then carry through to the upper plate and give us all the signals we need. So what we end up with is actually a pretty decent, I'm going to hit save on this, work back up the chain and save it all. What we end up with is a decent number of signals. I'm now starting to wonder if I should go one more. Like instead of going for an 8-way connector on each side, go for a 10-way connector and try to squeeze in another 4 GPIOs. I don't think it's really necessary though, because what we have, if we come back to the schematic, is we're going to have 4 power connections. So we've got all the power we need. We've got I2C, we've got SPI, and then we have 7 GPIOs, and we have USB. So if you're building some kind of a payload to run on top of the bot, and that is not enough connectivity for you, then I think the solution would be a sub-processor or having some kind of intelligence built into your thing on the top board that communicates with the main processor, rather than requiring even more I/O than that. I think that's enough to cover most of what people are going to want to do with this sort of thing. Yeah, okay, so I'm going to do a very quick bit of wrapping up here, just to leave this in a state that that is decent. So I'm going to change this to L riser. No, yes, L riser, R riser. Yes. Left riser, right riser. So let's put power on the right because, okay, orientation wise, the power supply is over here on the right. This is where we've got the 5.5 volt regulator, the 3.3 volt regulator is all over here. And the battery is, like the power and everything, is going to be coming in on the right hand side. So this connector should be the power connector. Where's pin 1? Down there. Okay, that makes sense. And pin 1 facing us. No, I need to rotate this one. 180. There we go. So pin 1 is bottom left in both cases. So power on the right, and then GPIOs on the left. So we're going to have 4 power pins, and then I think I squared C, and maybe I squared C and 2 GPIOs. And on this one, we will have USB and the 3 dedicated SPI pins and 3 GPIOs. I think that makes sense. So I want pin 8. So on the left one, I want USB plus and minus. I'm going to do it that way. So 8 is USB plus. I'm thinking about, so what I'm doing here is mapping the, I mean, ideally we'd have another ground pin on the left as well, but we've already got one ground connection. That will have to do. So we're not going to have a ground return path.
At Tinker001 said, change to 4x3, have power I2C on both sides.
4x3 and have power and 4x3 is not that easy to get though. You'd have to bodge it up by using single row headers. And have power and I squared C on both sides. 4x3, so that would gain us, but which power? One thing I don't like is not having a ground on both sides, because it means that the return path...
Does the GPIO interfere with USB or you're gonna move it?
The USB I'm going to move. That's that definitely has to move. So what we're going to end up with is really big ground loops if there is no ground pin on the riser, on both risers. Because the current return path is going to have to go all the way across the board, which sucks from an EMI point of view, a signal integrity point of view. So, isn't that a surf beach? Yeah, Gunner. Gunner is a surf beach. Do we go for a second connector, like make it a 3x4? Oh, I really want a ground on the left side. I would actually sacrifice a GPIO to get it. All right, I'm going to put in the knowns, and then we're going to. I've got to stop saying Gunner. It's lazy talk. I am not a Neanderthal. Okay, left riser. I'm going to not gonna, I am going to do D positive on 8, DP 3, I think. Positive going to the top, yeah, positive above, negative below, and it is port 3. Yes, that is correct. And so then I'm going to go DM3 on pin 7. So this gets us USB on the left connector. And I think that, simply for convention's sake, what I need to do is make pin 1 ground on both of them. And I'm going to work around that. So that is a fixed thing. Then what I can do is bring out, on the left side, I'm going to bring out SPI. And maybe I2C on this side, and then a whole bunch of GPIOs on this side, but definitely power on this side. No, I think GPIOs on this side because you always need a chip select with SPI. Yes. Okay. I feel that what's going to happen is I'm about to drop one of these GPIOs, but I'm okay with that. This is a plentiful sufficiency. We are fine for GPIOs. So what have I got? 35, 36, 37. Okay.
Hanging around too many truckies.
Hanging around too many truckies. Yeah, hanging around you too much. IO 35, IO 36, IO 37. All right, so we now have SPI and we've got ground and we have USB on the left connector over here, this one. Then on the right connector, what are we going to have? I'm going to move that a little bit further apart. Just to give myself room to breathe. I need to breathe. Okay, so we need all the power connections here. I am going to take that up to there, and I'm going to take that one up to there because I'm about to tack on some power symbols. I will tack 3v3 on here, yes, and I am going to tack 5 volts on over here, and yes, I do. Then let's give myself even more room to breathe. Move that. Yes, sure, why not? Then this one is going to be V in plus, so that we have the raw unfiltered power.
Can you check DC?
Did I check what? Can I check DC? What do I mean? What do you mean by check DC? I don't understand. Check DC? Have I screwed something up that you have seen and I have not? That is quite both likely and possible. Let's oh, Discord. No. Discord is always an annoying back channel when I'm doing a stream. It's much better to keep things in the chat on YouTube, because otherwise, yeah, I don't even have Discord open at the moment. I'd have to open it and then I end up losing, yeah, it diverts me off into some weird thing. All right, now I'm going to put I2C, I think I'm going to put it on pins 7 and 8, and I'm going to make it SDA SCL. So that's going to become what was SDA? Where was it? There we go. IO 6 and 7. Okay, 6 for SDA, IO 7 for SDL. IO 7? Yes. There we go. Then I'm going to assign to these remaining ones, I'm just going to assign the next IOs. So IO 8, IO 8, IO 9, IO 10 and 11. I think that gives us plenty of scope for whatever we want to do on the top board, which means we're not getting access to 12, 13, 14. We've only got, yeah, so where's my little copy thing? I do not have connections on 12, 13, and 14. I've broken out the nets, but they are not linking anywhere. So now we've got left riser and right riser. We have, just to recap, to refresh my brain in case I've screwed something up, we have ground, 3.3 volts, 5 volts, and V in. So we've got all of the power that we could need. We have I2C, we have USB, DM3, DP3.
Discord is a squirrel factory.
Yeah, it is the squirrel factory. We have SPI, and then we have an additional 4 GPIOs, which could be used for things like UARTs or just as GPIOs or for chip selects or for a second I2C bus, in fact, or whatever you want to use basically. I think that's enough. Unless someone...
C2713291 LCSC part number for 34 LCSC part number for 34 chat is a squirrel pult.
That went crazy. Oh, okay. So Henrik has been sending me to an LCSC part number. Let us see. LCSC. Yeah, you can get these things, and you can make them up out of just single strip as well. Yeah, so that's a 3-way pin header. So that's a 3x4. But I don't think it's necessary, and I think we would start running into problems with clearance. So this is a 2x4. If this became 3x4, it would protrude down further into here. Although I could always move it further up. There is plenty of room. I could remove more plastic up here and move the riser further that way and gain pins. So that could be done. Oh, do I want to? Should I even? If I did that, we could bring up heaps more I/O. Basically, everything we've got now, plus we would gain another 8 GPIOs. Yeah, Tinker says, I really was trolling with the 3x4 idea. Yeah. Yeah, but, okay. Doing this now does not prevent us from expanding on this idea in future. I could add another row. So what I could do in future...
Tinker001 said, I really was trolling with the 3x4 idea.
This reverb effect is very interesting on the TTS. So if I go... Keep in mind that what I'm trying to do now is get quickly, and I know everybody laughs, quickly, it only takes months, 6 months, to a first version that we can
power up to there.
try, that we can get into the hands of software people to start doing fun things with this. And doing this, as I'm doing it now, does not prevent me in future from adding a third row, bringing it forward.
Grant said, it seems like a lot of IO until you were trying to build a project and a one pin short.
That's true. All right, let's see what that would look like. I am going to add a 1x4 and drag it into place. So let's go. Let's go. I am so hungry. I need to stop soon. 1x M04 socket. This one, yes. So let's stick another row. In fact, let's do 2 we'll do a row on the left and a row on the right, and then go dum bum bum bum. And now I'm going to do some grid tricks, stupid grid tricks in Fusion.
Expelliarmus.
Expelliarmus. Yeah, in other words, get out. All right, so I'm going to do some stupid grid tricks in Fusion. I'm going to place these directly over the origin of the intermediate, and then plus that is that. So then if I come into the grid and change millimeter 3.81, I'm going to change the grid to 3.81 millimeters. And then if I grab that one and I move it north by one grid click, it will end up perfectly spaced. And here, that one grid click, perfectly spaced. So now we have a 3x4 just consisting of a 2x4 and a 1x4 that are butted up hard against each other. It could be a single thing or it could be two things, doesn't matter. Spacing is perfect. So I'll set the grid back to a sensible non-Stone Age unit, back to millimeters, ISO standard as God intended, and come back here. Okay, I'm going to save that. So what this would mean is I've got to modify the plastic a little. Oh, now that I've done it, now that I've come this far, I might as well do it.
At Grandmazel said, harder to fit the USB connector.
Yeah, that's true. That is true. I think I'm going to have to sleep on this one a little bit. Okay. Pull. The USB connector, I've moved it off the board just to stop it from visually interfering. And now this is doubled up. So we now have 3x4 on both sides of the board. And in this, you'll see that it now protrudes into the plastic. But that plastic can be modified. There is no problem at all with increasing clearance in here because there is still plenty of room. Let's bring that section analysis down. Edit that. I need to lower it. It's we're not seeing the connector intersecting at the moment. Bring it down to there. There we go. So if I bring this over here.
0001 said, since the especially cam being raised, could put the USB connector below it.
Put it below it. Ooh, put it right out the front. Ooh, interesting idea. I don't know that I like it, just because it seems weird to be sticking it in there. I don't know, maybe. All right, so what I can do is I can bring this plastic forward and bring more clearance around there, and also maybe make this wall a bit thinner so that the curve comes around, clears that connector, and then ducks in, comes around here. All right, I'm not going to do that now. In fact, I'm going to end the stream now because I'm nearly an hour over time. I'll save this. I'm not 100% convinced on going from a 2x4 to a 3x4. But I can see potential benefits to it. So what I'm going to do is, I'm going to wire them up. Will I, won't I? Yes, I will. Yeah. I am going to wire them up. So this one is going to go, I'm going to do that and then mirror that part. And then this one is going to, so that is on the 8 side. That is also on the 8 side. Okay, so I need to mirror this and flip it. Sorry, I'm doing stuff in my own brain that I'm not explaining to you.
On the add-on board. If the USB port is in the front, you could auto-dock the bot.
Auto-dock the bot. Yeah, I don't think it'd have enough force to be able, well, accuracy and force to be able to. Tata Uru? Yeah. I know, I should be going. I should not be here anymore. but I am just going to leave this in a slightly more cleaned up state. So I'm going to move that to there, yeah, to there, that'll do. Move this to, move this over here somewhere, about there. Okay, now let's get rid of that. Let's break out these pins. Break out pins, all pins to, yeah, that. And do the same on this one. Break out all pins to default net names. Then we've got IO 12, 13, 14, and 15 we could stick on here. So we could go IO 12, IO 13, 14, 15. 15 doesn't exist anymore because I deleted it. IO, it's off to work we go. IO 15, which does not exist. And then what else am I going to assign? 16, 17, 18, 21? Sure. IO 16, 17, 18, and 21. IO 21, which means if I now assign nets from here, I don't want to break out all the pins, so I'm going to do this manually. That's why I didn't just select the chip and then go break out all pins. So that is, because I'm wanting to control the assignment of these so I know what I've used and what I haven't. Stick a flag on there, 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 and there. Name them, and that'll match them up, and then we will end up with nets bound to the connectors. IO 16, IO 17, IO 18. I should have done one more. Yeah, I need IO 21 as well. Come on, there we go. Name IO 21. Reporting for duty.
Where is my daddy says BeetleBot?
Where is what? Where is my daddy says BeetleBot? Okay, IO 21. All right. So those nets are now assigned. And okay, I think what I'm going to do now is mark this as done. Power switch. Because we do not have the power switch in the circuit yet. We've just got this dogleg right here where the power switch is going to go. And we have those nets assigned. We have, where's the USB hub? Down here. So we've got spare DP3. Yep, these ones go to the riser. We've got,
Look at all those unused IO pins.
we got H bridge. Oh yeah, P ground. I've got a blink P ground on this side. Oh, that would have been bad. Come on. Yep, so we've got the H bridges set up with left and right motor connections. We have the S3. Yeah, I know, there's a whole lot of unused IO there. But still, we have got so much IO now brought out to that top board. So much. Then we got power, I2C, SPI. We've got a bunch of IO. We have all the nets assigned here. We've got a reset button. Ooh, should one of these be reset? That could, or, I mean, you can always use one of them as a software reset controlled by the S3. I'm wondering though if it is worth
More headers.
No, not more headers. I'm wondering if it is worth bringing the reset net up onto one of these pins, so that if you have a subboard that you want to reset, when you press the reset button on this, it gets reset. I have a feeling that might be worth doing. And I also have a feeling that I may regret it if I don't. So, where would I do? I think I would bring it up on the L riser, because typically what you would have is SPI with one I/O pin as the chip select. Yeah, I think I'm going to take IO9 on this pin and swap that and tie it to this reset net right here. So let's put a label on that net. It's currently called that. Let's give it a proper name of S.
With the extra headers, the reset is really good idea.
Reset. Yeah, I think this would be a regret if I didn't do it. So I'm going to take what used to be IO9 and I'm going to link that to just that. I'm going to link it to S3 reset. I'm directly exposing the S3's reset pin to the header by doing this, but I don't think that's a problem. I could apply a pull-up and use a diode, so it's like an open collector pull-down assembly, but I don't think it's necessary. I think just exposing the reset net is sufficient. So what we have now is IO9 is not being used anywhere, and then 10 onwards is. So I probably need to renumber everything. What I need to do is drop IO21 and renumber everything else backwards adjacent. Okay, I'm not going to do that now because my stomach tells me that if I try, I'm going to die. I'm going to not survive until the end of doing that. So D-link, I'm going to say unlink, I speak English, unlink IO21 and renumber to use IO9. That, IO9, because, yeah, that'll tell me what I need to know. I'll remember what that means. IO9 is currently unused, and Peter's suffering OCD that it's 1 p.m. Yeah. Oh, here comes a thing from Henrik. Henrik wants to see me dance. I'm not going to dance. Yeah, the echo will be good on this one. Come on, it's got to come through. Why is it not coming through? Is it because it's past 3 hours? What? No. All right, the last message that came through was, oh, here it is. Oh, that's classic. Oh, that was so good. Because that one already had a bit of reverb in it. And then the double text to speech. Henrik, thank you for the super chat. The 1.49 euros, which is about $100 Australian, I think, at the current exchange rate. Maybe $1 million, maybe more. Okay. I am seriously going to stop now because I am starving. And Tinker. Oh. Oh, that sounds so bad. It sounds like my computer is having an aneurysm. Trying to do the two TTSs at the same time. Okay. And Tinker, thanks for the 42 months of membership. That is really cool. Now, where are we leaving this? Okay, I am CD skipping. Yeah, yeah. It's a scratch on the CD. So we've got this with all its nets linked. I am going to pull the updates and save this. Oh, and Henrik is doing it again. More CD skipping. Here it comes. I think. Maybe. Maybe. Come on. Skip CD. Skip CD. He sent me a burger, now he's sending me a hot dog. It'll catch up. Reverb gone bad. Yeah. All right, we now have risers with fully allocated nets. Here it comes. Both of them. Oh, that's a disaster. Reverb going nuts. Okay. It's a hot dog, not a hot dog. Hot dog needs more sauce.
Eater a hot dog, not a hot dog.
Okay. We now have, apart from some little tweaks, we now have, I believe, a fully netted project. I need to do some little cleanups, like cosmetic cleanups and net renaming. Functionally it's fine, but net renaming and things on here to make it nicer, but I think the schematic is in good shape. The PCB, we figured out where everything needs to fit. I need to change the plastic slightly to add clearance for this extra header, and then I need to move all of this into place and route it. So, yeah, we're doing okay. We're doing okie dokie. Yeah. Updating. Oh, it is updated, okay. Yoink. And turn off the analysis. And save that one as well. Okay. Saving. Alright. And now I am going to quit out of Fusion. So next weekend do we have PCB ready and ordered, says Henrik. Well, that depends entirely on whether I work on this out of hours. Like when I say out of hours, I mean off the stream.
Next weekend we have PCB ready and ordered.
Yeah, if I do put some time into it outside of the stream, I could get this ready to go. Huncha. 89 cents each. These things are not cheap. Oh, the price drops dramatically. Okay, 12 cents in 150 quantity. The other thing I need to check is the distance.
Don't forget to like and subscribe and save to a playlist guru.
Thank you, Crispian. I'm probably going to need to use extended pin headers because the gap between the top and the bottom boards is significantly more than you would normally have with pin headers. My plan, I think, is to use 19mm pin headers on the top board facing down, not these ones. These are quite short. These ones normally only rise about 7mm, I think, above the plastic. Like 8 point something, I can't remember. Maybe 10.5mm off the board. So I would use 19mm instead of 10.5mm. Yeah, but thanks for finding those for me, Henrik. Okay, I am going to go. I'm going to bail. I am going to do my best to not pass out before my stomach gets something in it. So, thank you for coming along and for partaking in this journey. Remember, if you know of anyone who wants to buy a pick and place machine, hit me up. I have pick and place machines. It's John's Pick and Place Machine Emporium and something. So, yeah, I want to sell pick and place machines. You want to buy pick and place machines. Let's do a deal. Okay, so have a fantastic week, and I will see you back here next Sunday for my birthday. Tinker says free shipping. Yeah, I'll just put the pick and place machine in an express post bag and we will be done. All right, I will see you next Sunday, and yeah, do all the good things. Have fun. Enjoy life. And I will talk to you later. See ya.